Okay friends, so in this video we will be beginning with this question. So in this video we will be solving some questions, that's it, right? So this is the question that I have selected. Now see, a wheel of radius r and moment of inertia I. So they have given the specifications for the wheel here. I am taking a capital R because it is more convenient for me to write capital letters here. Okay, so it is inclined plane. Okay, there is a block here and it is attached to this particular pulley, and then this pulley is wound with the required amount of string. Okay, it's wrapped around the wheel. I mean, this is the wheel, which is the pulley, right? This wheel is the pulley here. This is the wheel and that is the pulley itself. Now what happens is that initially the wheel is rotating with the speed of omega in a direction such that the block slides up the plane. So this is the catch point over here. See, this particular block of mass m is moving in this particular direction, right? And this particular string is wound around the pulley and that is connected to this particular mass. So if the mass is going upwards, then the pulley is rotating in this particular direction, right? So the pulley is rotating in that particular direction. Only then the mass can go upwards. Okay, so the direction of rotation of the pulley is somewhat like this, and the arrow clearly shows this, and the specifications are I and R. How far will the block move before stopping? Okay, so we are just collaborating the concepts of linear motion in this particular rotational motion concept. So this is a good collaboration type of a question. So let's understand how to solve this. So first of all, let me tell you what is the acceleration here. Whenever we get a question like this, whatever we have learned till now is to find out the acceleration. And to find out the acceleration, we need something called by the name of a free body diagram. So let's understand the free body diagram in this particular question. This is obviously capital M G sine theta, where theta is the angle of this inclined plane. Now consider this as T. This is the tension. Only one string is given, so one tension, that's it. Okay. Now the easier method is to consider this as a complete system. So the tension and the torque acting on the pulley will be definitely an internal force. Mg sine theta is an external force. So what is the acceleration here? Acceleration will be directly equal to mg sine theta, that is net external force. This is to be divided by the total mass. So one of the mass is m and the other one is the mass of the pulley. But here, since the pulley is rotating, I have to consider it as I divided by r square, where r is the radius of the pulley, which is given in the question. Okay, if you want me to write the force equations, it is very easy, right? If this is the mass m and this mass is actually decelerating upwards, this mass is decelerating upwards, that means there is a acceleration that opposes motion. What is deceleration? The deceleration is not negative acceleration. Deceleration is actually acceleration that opposes motion. Okay, so that is a very important sentence. It is given in your NCERT textbook. Mark it in the topic of laws of motion or something. This is a very important concept that you are supposed to remember. Deceleration is not the negative acceleration. Deceleration or retardation simply means it is the acceleration that opposes motion. So what is here? What is happening here? This particular body is having a deceleration in the upward direction. So that means mg sin theta force is maximum. So more than t. So mg sin theta minus of t is equal to m multiplied by a, and the second equation that you can find out is t is equal to ia divided by r square. Since we have done these things previously, we will be simply using this, and if you solving this, you will get this particular equation as such. So you can solve this also, and you can also take up a very simple approach, that is net external force divided by the total mass. In place of the mass of pulley, you have to substitute I by r square, right? And now they are saying how far will the block move before stopping. So block is having a linear motion here. Now what does the v square is equal to u square plus 2as, so that is 2as. Okay, this is how you can solve this. So distance is equal to v square divided by 2 multiplied by a. So v square I can substitute it as r square omega square. This is divided by 2 multiplied by a is this particular value. Let us plug in this value over here. Mg sin theta divided by m plus I by r square. Okay, so this is the answer for this particular question. So this is almost an easy question. You can expect this kind of a question to be appearing in your NEET exam as well. If they want to make it slightly more conceptual, slightly more tougher, then they can go for these kind of questions. But this is a very standard question, and please make a note of this. You can revise these questions before the exam as such. There is no harm in doing that. Okay, this is also a very simple question, but here just in the interesting fact is that we have collaborated the equation of linear motion with the concepts of rotational motion. Okay, let's proceed to the next question. Okay guys, so this is the second question I'm taking. Two masses M and capital M and small m as given in this particular diagram are connected by a light string. Okay, string doesn't have any mass. It is going over a pulley of radius r. So I prefer capital letters. That is why I just wrote it as capital letter. Okay, so it says that the pulley is free to rotate about its axis, which is kept horizontal. Okay, fine. The moment of inertia of the pulley about its axis is I. Moment of inertia. Okay, specifications. The system is released from the rest. Okay, find the angular momentum. We are supposed to find something which is very thought-provoking as far as our rotational motion is concerned. Angular momentum, L vector. Okay, of the system when the mass M has descended through a height h. Okay, fine. So this is actually mass M is more than small m, right? So this will descend down, and after some time this new mass, this will be the position of M. It has descended through a height of h. Now at that particular moment, if this particular mass is descending through a height of h, since these two masses are connected by the same string, this mass will also go up by h. Fine. So this is how it goes. This is the new position. Fine. Now they are asking us at this particular moment, what is the angular momentum of the system? So L vector is equal to I omega, or you can keep it as MVR. Okay, so L vector is equal to I omega, and omega can be written as V by R, isn't it? So since V is equal to R omega, I can keep it as I multiplied by V by R. Okay, V is the velocity of the system. So how to find this out? For this kind of a question, I think we'll have to use the concept of the energy conservation. That what we'll be doing is energy conservation. See, when this particular mass is actually coming down, then the potential energy lost is actually mg multiplied by h. Okay, mg multiplied by h. Now this is the net potential energy that is lost over here. Now this is actually going upwards, so it is gaining potential energy. So this is again small m multiplied by g multiplied by h. Okay, so this is the net potential energy you can keep. Okay, so this is equal to m minus m multiplied by gh. So this is the net potential energy over here. Now this is actually converted into the kinetic energy of the system. Fine. So how will I write the kinetic energy of the system? For the kinetic energy of the system, I think I will have to use something like half mv square. See, half capital M multiplied by v square plus half small m multiplied by v square. So both the masses have been considered, plus of half I omega square. Omega square is equal to v square by r square. Okay, now this is the net kinetic energy, this is the net potential energy, that will be equal. So m minus m, loss of potential energy, will be equal to gain of kinetic energy. M minus m multiplied by gh, this is equal to this particular equation. From here I can take half v square outside, isn't it? Half v square outside, then I will get here m is remaining. Now here small m is remaining, plus here actually I by r square is remaining. Now this is equal to m minus m multiplied by gh. So this implies, what is v square then? M minus m multiplied by gh divided by m minus m multiplied by gh. Now this 2 also goes upwards, isn't it? So 2 multiplied by this upon m plus I upon r square. So this is the big equation. So in place of v square, if I want to understand what is v, then I will have to take the square root of this particular thing. So if I take the square root of this particular thing, I will get something called by the name of v. Now it's a matter of just completion sake. So you will get a big equation over here, but understand the concept as such here. See, L is equal to I omega. I will be using this. Now this is equal to I multiplied by V by R. Why? Because you know the pulley, if it does this, then the strings are not slipping across the pulley. Okay, if the strings are not slipping across the pulley, I can use omega equal to V by R. So in place of V, you can substitute this particular equation. There is an I over here, okay, and R. You can try to simplify that. So that is the explanation for this particular question. So you can simply put this particular equation in this particular value. Okay, so that's how we can solve this question. Let's proceed with the next one. See guys, this is a wonderful question, and this is the last question that I will be solving to end this particular lecture on the entire concept of pulley. Okay, so this is my third question in this particular video. Just look at how nicely sir has coordinated all multiple concepts from 3 different aspects to make this kind of a question. See, let's go through this. First of all, consider the situation. We are supposed to consider this situation shown in this particular figure, right? The elevator is going up with an acceleration of 2 meter per second square. So what is the acceleration of the elevator? It is 2 meter per second square as it is given in the question. And the focal length of this particular mirror is equal to 12 centimeter. See, understand that this is a convex mirror. Okay, so if it's a convex mirror, by sign convention, we will be taking this as positive. All the surfaces are smooth and the pulley is light. The pulley is light. So that means if the pulley is light, simply I can say that if this tension is T, then this tension is also equal to T. Okay, so you can very easily make the equations from whatever classes that I have taken, whatever discussions that we have previously had. See, at least you can identify directly what is the acceleration here. Acceleration is equal to net external force. The net external force is only mg, small m multiplied by g divided by m plus m, that is the net mass. Pulley is massless, frictionless. I don't have to consider I by R square at all. There is no torque acting on this particular pulley because on both sides the tension are equal. Okay, now let us understand what is very much fabulous in this. See, this is a condition of accelerating lift. Now as you go upwards in an accelerating lift, you will see that your weight is increasing. Why is that happening? See, inside an accelerating lift, if I am considering a body inside this particular accelerating lift going with an acceleration of A upwards, then if this is a body inside the accelerating lift, then there is obviously a G acceleration downwards. But obviously there is a pseudo force. There is a pseudo force due to this particular acceleration which is going upwards. So the so that pseudo force will be in this particular direction, and the acceleration due to the pseudo force will be also in the downward direction. So the net acceleration is equal to A plus G. Right? So this is the G effective. You can write G effective is equal to A plus G. So that whatever acceleration is towards the direction, downward direction, that is acceleration due to gravity. But here you will be adding this because the pseudo force is in this particular direction. So whatever is here, this is actually the G effective, not G. Okay, that is G effective. And what is G effective? G effective is G plus A. Acceleration is 2 here and G effective is 2. So what is G effective here? Obviously that is nothing but 2 plus 10. I will take this as 12 meter per second square. Okay, I hope you got this particular concept as such. This is what we need to understand from the concept here, that whatever the question center is trying to tell us. Okay, now what is this here? See, this is m by 2m, now G effective. So that will be directly given as 12 is G effective, isn't it? That will be 12 by 2. This will be 6 meter per second square. So we got the acceleration which is in the downward direction, right? Okay, so they are saying that the mass pulley system is released from rest. So U is equal to 0. Obviously they have said that U is equal to 0. We know the acceleration is equal to 6 meter per second square in the downward direction. Now at time t equal to 0, when the distance B from the mirror is 42 centimeters. So initial distance of this particular block from the mirror is 42 centimeter. Find the distance between the image of the block B and the mirror at time t equal to 0.2 seconds. Okay, so what is the distance traveled then? Half ut is 0, u is equal to 0 multiplied by 6 multiplied by 0.2 square, that is 0.04. Right? So this if I cancel, I will get it as 12 centimeter. Fine. This is 12 centimeter. Now what I'm supposed to do is that the initial distance from the mirror was 42, isn't it? And now it has descended as more distance of 12 centimeter downwards. So the new value is, total was 42. Now it has come down by 12. So what is the new distance which is there? That is U value. U, that is object distance from the mirror, is actually equal to 42 minus 12, that will be equal to 30 centimeter, right? 30 centimeter, you have to take it as negative because we are actually following the appropriate sign convention. So U is this much, the focal length of this particular convex mirror is plus 12 centimeter, right? We are simply supposed to find the V value, that is image distance from the mirror. So you can simply substitute this in 1 by V plus 1 by U is equal to 1 by F, considering the appropriate sign conventions. You can just do that. I'm not solving this mathematical application, this mathematical calculation, because if I do that, then the length of this video will be too much. So if you do that, this is a very simple calculation. You can do that at home. Once you do that, V will be equal to plus of 8.57 centimeter. You will be getting this particular value in that particular question. Okay, so this is a wonderful question that the question setter has made. He has collaborated almost 3 concepts. Okay, the concept of geometrical optics is here, the concept of loss of motion and the pulley concept is there, and then the concept of an accelerating lift, where the concept of your pseudo force comes into picture, right? So that's what I plan to tell you, that's what I plan to teach you in the entire concept of pulley based questions. Okay, so with that we are winding up this particular lecture. So if you like this, please like, share and subscribe to my channel. Click the bell icon to receive notifications whenever I upload these kind of videos in YouTube. Revise these things consistently, be consistent in your approach, and definitely you will, for 100% sure, I'm saying that, I can say this 100% surely, that you will definitely succeed in whichever exam you are writing. Okay, thank you.